Problem solving with algebra, solving word problems with using algebraic techniques, in particular sort of quadratic equation type situations. A border is to be created around an existing lawn, shown in green here, 40 by 50 meters. Okay, so the lawn was 40 by 50 around the outside, and it reduces the area, so this is the little border here, it reduces the area by 344 meters squared. So what we need to do is find out how wide the border is. So first thing we do is we're going to do is use a red pen, and we're going to say, let's make the width of the border here X. So it'll also be X across here. It'll also be X wide here. So it's going to be the same width all the way around, and that width is going to be X. So what we do is we write down let X equal border width. Okay. Now, once we do that, we can see that the length of the reduced lawn, this dimension here will be 50 minus 2x, and this dimension here will be I'll write it in here because I can't seem to write it up the way too good. 40 minus 2x, and we'll just put an arrow in there like that. So we know for a start off that the area of the existing lawn will equal 50 by 40 meters, and that's going to equal 2,000 meters squared. Now, the area of the existing pond, or the area of the reduced lawn I'm going to write that under here actually, will be 40 minus 2x times 50 minus 2x. Okay, and that's going to equal 2,000 minus 344, which equals, to get our calculators out, and that's going to, let me see what that equals. Get my calculator out. 1656 meters squared. 1656 meters squared. So there we are, we have an equation in x that we need to solve to find the width of the border. So we must multiply this all out. So just to multiply that out, it's equal to 40 times 50 minus 2x minus 2x times 50 minus 2x, and I'm going to put over that equals 1656. Okay, so let's multiply that out. So we get 2000 minus 80x minus 2x times 50 is 100x plus 4x squared minus 1656. So I'm just going to take 1656 off both sides to equate that to 0. Okay, now let's see what we've got there. We've got 2000 here minus 1656, but let's just start with our highest power. So we've got 4x squared, so we'll put that down there, 4x squared. Now we've got minus 80x minus 100x, which is minus 180x, and then we've got 2000 minus 1656, which is going to be plus 344 equals 0. Now what we can see here is that we've got this 4 here, so we're only looking for x. So as long as we do the same thing to the whole equation, it won't matter. Now we can see that 4 goes into there once, so that could become, I'll get my red pen out, so we'll just divide through by 4. So 4 goes into 4 1 times, 4 goes into 184, 4's are 16, and 2 45, and so that's crossing out the 180, and then the 344, 4 8's are 32, 4 6's are 24. So now we can I've just divided through by 4. It doesn't affect our equation, so now we can go through and rewrite our equation as x squared minus 45 plus 86 equals 0. Now if we look at the factors of 86, we've got 1 times 86, 2 times 43. And what we're looking at here, we've got a positive sign here, so that should be an x there. We've got a positive sign here, so that tells us that in our brackets, if we were to reduce our brackets here, like so, 0, in our brackets, that tells us that both the signs are the same. And if we look here, that tells us that they're both negative. So x, x, and they're both negative. So what we're looking for is two numbers that when multiplied together are 45. So we've got 2 times 43. So we can put a 2 in there and a 43 in there. And that solves our equation. Now, the equation equals 0. So when x minus 2, so here we've got two factors multiplied together, and the equation will be 0 if either one of those factors is 0. So when x minus 2 equals 0, x equals 2. So that's looking good, and for the width of our path. And when x minus 43 equals 0, oh sorry, I'm just going to erase a little bit there and put the proper terminology in. I'll just I'll just edit, cut. So so we go back to our brush. So either for that equation to be 0, either x minus 2 equals 0 and x equals 2, or x minus 43 equals 0 and x equals 43. Okay, now 2 is the only practical solution. 2 is the only practical solution. This SOL solution. So therefore we can say width of border equals 2 meters. Now, it's not always the case that the quadratic equation works out to a nice even number like 2. I mean, it could have been 1.8. Obviously would have been a different area. So this is a very easy solution here. I'll just write up in here that there's always the possibility, we'll just create a little bit of a area for notes in here. There's always the possibility of so for more difficult solutions, for more difficult problems, we can use the quadratic equation, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm just putting that there for future reference, so that if you were to be doing a problem like this and it didn't come out to a nice easy answer like the 2 meters that we've got here, that you could, if you're familiar with the quadratic equation, use that. If you're not familiar with it, look up about it and find some more information. So there you are, problem solving with algebra using quadratic equations.